I think that the main advantage would be that it can happen in ambient temperature and pressure. So we don't need a very explosive gas or something. It can be done simply by electricity. You can convert CO2 to something else with electrochemical CO2 reduction. It has this potential to go towards very selective products depending on the catalyst that we have. It can give us product selectivity and purity. It also has low reaction steps compared with other reactions.
And compared to, let's say, biological conversion steps or microbial conversion steps, it goes faster. So you can have in a short duration of time. From a research perspective, you can screen a lot of catalysts in a short period of time, which is while with a bacterial system or a microbial system, it takes several months. So that's another advantage. And final advantage is, of course, the possibility to integrate the electrochemical systems with renewable electricity. So for a very long time, the research on electrochemical CO2 reduction was at low technology readiness levels, TRL levels as the European Commission calls them. And the main idea was only on proof of concept, and that we can make X, Y, and Z product starting from CO2 and using an electrochemical approach. So a lot of emphasis was on a discovery of new catalyst, and it's only in recent years that projects and efforts have come up in upscaling the systems. So for instance, in one of the recently concluded project that we did on LOTER 2M, we made a 5 kilowatt CO2 electrolyzer for conversion of CO2 to methanol, which is actually being tested right now in RWE, which is a German company, with real flue gas for converting to methanol. In the next step, we have a Green Deal project where we will make it more even at a higher TRL, and we will make a 50 kilowatt electrolyzer. But apart from that, the Commission is also funding a lot of projects via Innovation Fund, which is one of the biggest funding schemes to support such CCU projects. So I'm very hopeful that in the coming 4 to 5 years, you will see a lot of pilots and demo plants on the ground.
It can be, I would think, of first integration designs, because we need to be careful when designing that the products on one reaction doesn't prevent the other other reactions happening. Also, the durability is important, because one of the challenges is how to go CO2 electrochemical reduction towards longer term, more than a few days or so. And also another challenge is synchronizing the reaction rates. We have for CO2 electrochemical reduction, we have very high, very fast kinetics, so it can happen very quickly. But for microbial conversion, we need longer time, so we need to kind of find a proper compromise between these two reaction rates, and these are the challenges at the moment.
And if I may add, I think one of the challenges of integrating this thing is how to deliver hydrogen to the biocatalyst. So in a lot of microbial conversion reaction systems or microbial electrochemical conversion systems, the pathway is via hydrogen, so rather than direct electron transfer. So how to supply or produce that hydrogen in a most efficient way, energy cost effective way, and to supply it to the biocatalyst in a shortest possible mechanism, that's one of the challenges that should be also solved. If I'm being optimistic, I would say not very far. I have 5 to 7 years, but of course that's a more optimistic researcher's point of view. I would like to happen it tomorrow, and if not yesterday. But I think a more realistic will be still a decade or so away, given the current pace of investments in the field and the R&D efforts that are going on not only in Europe but globally. Because there are already a lot of startups that have come up, and a lot of these startups have come up only in the last 3 or 4 years. So even if I assume that not all of them will be commercialized in few years, at least some of them will survive and grow and make a marketable product. So that's my hope, but a reasonable timeline will be from 10 to 15 years. We should have a real industrial commercial scale CCU plant.